Hello everyone! In this video, I'm going to discuss the concept of derivative. What is a derivative? So to understand the concept of derivative, let us have first the graph here. So we have here the x-axis and the y-axis, and this blue curve here is the graph of y as a function of x, and you will notice here that we have three tangent lines drawn in this function. So the slope of each tangent line in this function differ from each other. Now, if we're going to focus our attention on just one line or just one tangent line of this curve here, so let me just erase this one and line 2, right? And if we're going to determine the slope of this tangent line here, let us first recall the concept of the slope of a line. So say for example, we have a given line here, and then we're going to determine the slope of this line. And the slope of this line is actually equal to the change in y over the change in x, or that is what we call rise over run. So if we're going to pick up 2 points of the line here, right? So if we're going to pick up 2 points on the line, and then we have here the change in x and then the change in y. Now the ratio of the delta y and the delta x is actually the slope of this line. And if you're going to notice that at any given point of this straight line, the slope would be the same. However, in this particular function, right, so since we have a curve here, the slope of the tangent line at this point differs from the slope of this line. And the slope of the tangent line at this point differs from the slope of this line. So how are we going to determine the slope of a tangent line, right? So how are we going to determine the slope of a tangent line of a given function? So let me just erase this one. Now, say for example that we're going to consider 2 points, right? So if we're going to consider 2 points on the given function here, so we have here delta x, and this is our delta y. So this is our delta x, and this is our delta y. Now, since the slope of a tangent line is delta y, or since the slope of a line is delta y over delta x, and we considered 2 points on the function here, on the graph here, if we're going to determine the limit of the change in y with change in x as delta x approaches 0, then we can already solve for the tangent of this point. Because, say for example, we're going to consider 2 points here, and then the change in delta x here would be smaller than the change in delta x here. And again, we're going to consider 2 points in here. So again, we have a delta x here and then delta y here, and then the change in delta x here would be significantly smaller than this one. And if we're going to determine the limit of delta y with respect to delta x as delta x approaches 0, then this is now the slope, right? The slope of the curve at a given point. That is now the slope of the curve at any given point. Right? And this expression here is actually the derivative of y with respect to x, or it can also be denoted as f prime of x. All right? Now this concept of derivative can also be used in the application of rate of change. All right? So if we're going to summarize this discussion, the very definition of a derivative of a function y, right? So if we're going to have a y equals function of x, and if we're going to determine the derivative of this one, which is denoted by dy over dx, then that is now equal to the limit of delta y over delta x as delta x approaches 0, right? And it can also be denoted by y prime, or it can also be denoted by f prime of x. Alright, so this is now the definition of the derivative. Now that we learned the definition of derivatives, let us now apply that concept to find the derivative of a given function. So again, the derivative of y with respect to x is equal to the limit of delta y over delta x as delta x approaches 0. But how are we going to solve for the derivative of this one? Right? So there is a 5-step, that we use to differentiate a given function. So the first one in the 5 steps, right? So the first one is to replace x and y, right? So to replace x and y with x plus delta x and y plus delta y respectively, right? So if we're going to do this one, if we're going to perform step number 1, we're going to replace y with y plus delta y, so that would be y plus delta y, and this is now equal to, right, so if we're going to replace this one, we have x plus delta x quantity squared plus 3 multiplied by x plus delta x minus 1, right? So that is step number 1. Now, for step number 2, we're going to solve for delta y. Alright, so for step number 2, we're going to solve for delta y. And to solve for delta y, we're just going to transpose y to the right side. So we have delta y that is now equal to x plus delta x quantity squared plus 3 multiplied by x plus delta x minus 1, and the transposition of y would now be negative y. Now the third step is to transform, alright, so to transform the right side into 1, right, so into 1, where delta x is expressed explicitly as a factor. Alright, so where delta x is expressed explicitly as a factor. So in here, we're just going to expand this one, alright? So we're just going to expand x plus delta x quantity squared, and then we're going to distribute 3 plus delta x, and then we're going to substitute the value of y, which is actually x squared plus 3x minus 1, and then we're going to express delta x explicitly as a factor. So if we're going to perform the operation now, we have delta y equals x plus 2x delta x plus delta x quantity squared. So this is actually the expansion of x plus delta x plus 3x plus 3 delta x minus 1. And the value of y is equal to x squared plus 3x minus 1. So if I'm going to substitute that one, we have negative x squared plus 3x minus 1. Right? So if we're going to simplify this one, we have delta y. This is now equal to x plus 2x delta x plus delta x squared plus 3x plus 3 delta x minus 1 minus x squared minus 3x plus 1. And if we're going to collect similar terms here, we have x, right? So this must be x squared. So x squared, because I forgot to write it there, but this is the correct expansion of this one. So that's x squared, and this must be x squared as well. So x squared minus x squared, alright, so that will cancel out. And then we have 2x delta x. Alright, so that's the only term that involves x and delta x. So that's 2x delta x. And then we have delta x squared, 3x minus 3x. So that will also cancel out. Alright, so x squared minus x squared, that cancelled out. And then we have 3 delta x. Alright, so minus 1 plus 1, so that will also cancel out. Alright, so the simplification of this expression is now equal to 2x delta x plus delta x squared plus 3 delta x. And the third step here is to transform the right side of the equation into one where delta x is expressed explicitly as a factor. So we're just going to factor out delta x in this expression. And the factor out of delta x here would now be delta x multiplied by 2x plus delta x plus 3. Alright, so this is now delta y equals delta x 2x plus delta x plus 3. Now, the fourth step is to divide both sides by, alright, so divide both sides by delta y, or delta x, I should say, right? So if I'm going to divide both sides by delta x, we'll now have delta y over delta x is now equal to 2x plus delta x plus 3. So this is now the fourth step. And the last step here is to determine the limit of delta y over delta x as x approaches 0. And this is now actually the definition of dy over dx. So determining the limit, or determining the derivative of y with respect to x, this is now equal to the limit of delta y over delta x is this function, so that is now 2x plus delta x plus 3 as delta x approaches 0. Now, since our function in here, alright, so since our function in here is sum of terms, therefore we can determine the limit of each term independently. So this is now equal to the limit of 2x as delta x approaches 0 is actually 2x. Alright, because it is on the theorem of limits, or it is on the theorem on limits, where the limit of a constant as x approaches a is equal to a constant. And since x here is delta x, we're going to consider x here as constant, right? So plus the limit of delta x as delta x approaches 0, so that would be f of a, and since a here is equal to 0, then that is equal to 0. And lastly, the limit of delta x, the limit of 3 as delta x approaches 0, that is equal to 3, right? So that that also falls under this theorem. Therefore, the derivative of y with respect to x is now equal to 2x plus 3. Alright, so if we're going to recall the 5 steps differentiation, and if we're going to summarize it here, the first step is to replace x and y by x plus delta x and y plus delta y respectively. The second step is to solve for delta y. After solving for delta y, we're going to transform the right side into one which contains delta x expressed explicitly as a factor. Now divide both sides by delta x to obtain delta y over delta x, and then after that we're going to determine the limit of delta y. Alright, so this must be delta y over delta x. So determine the limit of delta y over delta x as delta x approaches 0. Alright, so let's have another example here. Now, say for example that we are given a function y equals x plus 3 quantity squared, and we're going to determine the derivative of this one, right? Or we're going to determine the limit of delta y over delta x as delta x approaches 0. So, to do that, we're going to use the 5 steps differentiation that we discussed in here. So, the first step here is to change y to y plus delta y and x to x plus delta x, right? So, we have y plus delta y equals x plus delta x plus 3 quantity squared, right? So, after this, the second step here is to solve for delta y by transposing y, right? So by transposing y to the right side. So we have delta y that is now equal to x plus delta x plus 3 quantity squared minus y, right? So if we're going to expand this first, the expansion of a trinomial is actually the square of the first term plus the square of the second term plus the square of the third term plus the sum of twice the product of each pair of terms. So this is now equal to x squared plus delta x quantity squared plus the square of 3, which is equal to 9, right? And then the remaining terms would now be equal to twice the product of x plus delta x, 2x delta x, plus twice the product of x times 3, so that would be 6x, plus twice the product of 3 times delta x, so that is 6 times delta x. Right? So let me just repeat this one. The square of a trinomial is equal to the square of each term, the sum of the square of each term, plus twice the product of each pair of terms. So the square of x, the square of delta x, the square of 3, and then twice the product of x and delta x, twice the product of x times 3, and the product of 3 and x times 2. Right? So minus, right, so let us not forget our y here, and y is equal to x plus 3. And the expansion of x plus 3 is x squared plus 6x plus 9. Right? So we have negative x squared plus 6x plus 9. Right. Now, if, right, so for step number 3, we're going to transform the right side into which uh, we're going to express delta x explicitly as a factor. And to do that, let's first simplify this one. So if we're going to collect similar terms here, we have delta y. This is now equal to x squared minus x squared. That will basically cancel out. And we have delta x squared, right? So we have delta x squared. And then we have 9 minus 9, so that will also cancel out. 2x delta x, so plus 2x delta x. 6x minus 6x, okay, so that will cancel out. And lastly, we have 6 delta x, so plus 6 delta x. Right? So now let us express this side as a factor of delta x. So if we're going to factor out delta x here, we have delta x plus 2x plus 6. Right? And then the fourth step is to divide both sides by delta x. So delta y over delta x, that will give us delta x plus 2x plus 6. And for the final step, which is step number 5, we're going to get the limit of delta y over delta x as delta x approaches 0. And this is now equal to the limit of our delta y over delta x here is this expression, so that would be delta x plus 2x plus 6 as delta x approaches 0. Right? So the derivative with respect, the derivative of y with respect to x, okay, so we can write this expression into dy dx, or we can write it as y prime if you prefer to write it that way. So this is now equal to the limit of delta x as delta x approaches 0 is 0. The limit of 2x as delta x approaches 0 is 2x. And the limit of 6 as delta x approaches 0, that's equal to 6. Therefore, dy over dx is now equal to 2x plus 6. Alright, so let's have another example here. Determine the slope of y equals 2 over x plus 3 at the origin. Right? So, in the beginning of our discussion, right, in the beginning of our discussion in derivatives, the slope of a function at any given point is equal to the derivative of the function. So, if we can determine the derivative of the function, and there is a given point, we're just going to substitute the given point in to the derivative of the function. Alright, so if we can solve for the derivative of this one, and the given point here is the origin, that means to say that x equals 0 and y equals 0, or that is 0.00. The first thing that we're going to do here is we get the derivative of this one. So in solving for the derivative of y equals 2 over x plus 3, using the 5 steps differentiation, right? So the first step is change y to y plus delta y and x to x plus delta x. Right. Now the second step is to solve for delta y. So we have delta y equals 2 all over x plus delta x plus 3 minus y. So if we're just going to substitute the value of y in here, we have 2 over x plus delta x plus 3 minus 2 over x plus 3. Alright? Now, if we combine, or if we're going to simplify these two terms, we have the LCD would now be x plus delta x plus 3, and we have x plus 3. Right? So that's the LCD of these two fractions. So we have 2 multiplied by x plus 3. So if we're going to combine now, minus 2 multiplied by x plus delta x plus 3. And if we're going to simplify this one, we have, right, so we have 2x plus 6 minus 2x minus 2 delta x minus 6 all over x plus delta x plus 3 multiplied by x plus 3. Or if we expand this one, alright, so if we expand this, we have x squared plus delta plus, alright, so that's x delta x plus 3x plus 3x, right, so plus 3x plus 3 delta x and then plus 9. Alright, so the expansion of this one, that is x times x squared, delta x times x delta x, 3 times x, 3x, and 3 times x, 3x, 3 times delta x, 3 delta x, and 3 times 3, that's equal to 9. And if we're going to simplify this, 2x minus 2x, 6, and negative 6, so this is now equal to negative 2 delta x. All over, we have x squared, 3x plus 3x, so that is plus 6x, and then we also have delta x here, so that is x delta x plus 3 delta x plus 9. Right? So the only similar term in terms in the denominator are 3x and 3x. That gives us 6x here. Okay? So this is now equal to, if we're going to express this side explicitly as a factor of delta x, then we can bring out delta x here. So we have delta x multiplied by negative 2 all over x squared plus 6x plus x delta x plus 3 delta x plus 9. Right? So this is now delta y. Now for the third step is we're going to divide both sides by delta x, thus giving us delta y over delta x equals negative 2 all over, right, so we have x squared plus 6x plus x delta x plus 3 delta x plus 9. Okay, so now for the last step here, alright, so this is step number 3, I should say, and this is step number 4. For the last steps here, or for the last step here, I should say, determine now the limit of delta y over delta x as delta x approaches 0. So to do this, we're going to determine the limit of the numerator and the denominator independently. Now, the limit of 2 with respect to the limit of 2 or negative 2 as delta x approaches 0 is negative 2 all over. Right. So, the limit of the denominator, we can determine the limit of the denominator independently. Right? So, since we have sum of terms here, the limit of x squared as delta x approaches 0 is x squared. The limit of 6x as delta x approaches 0 is 6x. The limit of x delta x as delta x approaches 0, that is equal to 0. The limit of 3 delta x as delta x approaches 0 is also equal to 0. And the limit of 9 as delta x approaches 0 is equal to 9. And if we're going to simplify this, dy over dx, that is now equal to negative 2 all over x squared plus 6x plus 9. Right? So this is now the slope of the curve or function y equals 2 over x plus 3 at any given point. Right? So at any given point, or that is the instantaneous slope of the function. Alright, so that is the instantaneous slope of the function. Now, to determine the slope, right? So to determine the slope of y at origin, so we're just going to substitute the value of x, which is equal to 0, to this derivative. So this is now dy over dx equals negative 2 all over 0 squared plus 6 times 0 plus 9. So the slope of the function at x equals 0 or at the origin is now equal to negative 2 over 9.